Why isn't triangle angle sum always 180 degrees? Imagine drawing a triangle on a flat piece of paper. No matter how you draw it, the three angles inside will always add up to exactly 180 degrees. That's a rule in flat or Euclidean geometry. But what if you draw a triangle somewhere else? Like on a curved surface? Suddenly, things get interesting. The sum of the angles might be more or less than 180 degrees. This is because the rules change when the surface isn't flat. In curved spaces, the usual rules of geometry don't always apply the same way. On a sphere like the surface of the Earth, triangles have angles that add up to more than 180 degrees. For example, if you draw a triangle using lines of longitude and the equator, the angles at the corners will add up to more than 180 degrees. This happens because the surface curves outward, making the angles, spread out, more than they would on a flat surface. This kind of geometry is called spherical geometry. It's used in navigation and astronomy because planets and stars are curved surfaces, not flat. Now, on the other hand, if you look at a saddle-shaped surface, the angles of a triangle will add up to less than 180 degrees. This is called hyperbolic geometry. The surface curves inward, so the angles seem to shrink. Think of it like a saddle or a Pringles chip. The rules of flat geometry don't hold here either. The difference between the actual sum of the angles and 180 degrees is called the angular defect if the sum is less than 180 degrees, or the angular excess if it's more. This difference shows how curved the surface is. The more the angles deviate from 180 degrees, the more curved the surface must be. So, in simple words, the reason why the sum of the angles in a triangle isn't always 180 degrees is because the surface the triangle is on can be curved. On flat surfaces, the angles always add up to 180 degrees. But on curved surfaces like spheres or saddle shapes, the rules change. This helps us understand shapes beyond just flat paper and opens up new ideas in navigation, astronomy, and advanced geometry. It's fascinating to see how the shape of the space itself can change what we expect about triangles and their angles.